All right, guys. So today we're going to do solving interest problems. So these are word problems. We're actually going to use exponentials and logarithms to solve. I'll tell you, this is my second go at making this video. I quit and reworked everything and made a new paper, and it was just taking forever. It's like over 30 minutes long, and I wasn't even done with it. So yeah. All right. So here's what we're going to be learning today. We're going to be learning the compound interest formula, which is here, and how to use it. And we're going to be learning the continuous interest formula right here and how to use that. Before we do it, I want to do a quick review of the simple interest formula, which honestly, the level of math for simple interest is, middle school, 7th, 8th grade. Not to insult your intelligence, just to lay a little background. So interest applies to whenever you borrow money or invest money. It's extra that you either have to pay back, or in an investment, it's extra that you get paid. The formula for simple interest, you simply multiply the various components together. P times R times T equals interest. P stands for principal. So like if you borrow $500, $500 is the principal. If you invest $10,000, $10,000 is the principal. Rate is a percentage, so like 5% would be 0.05. I hope you remember when you learned percents way back in the day, they always move the decimal 2 places over when you work with a percent. So, and then time is in years, it's T. T stands for time. And the thing with simple interest is the interest is calculated one time out of the whole life of the loan, and that's it. And it's just multiplied together, and that's the end. Now there's a second formula that goes with it, the amount, like the final amount. So like let's say, you invested $10,000 and it earned $2,500 in interest. Well, of course, you'd add those together and get a final amount of $12,500. It should kind of just be common sense. Or if you borrowed $10,000 to buy a car and the bank charged you $2,500 in interest, then $12,500 is how much you spent total on the car. So A is like the total amount. Okay, so the simple interest formula is you multiply the principal times the rate, which involves moving the decimal, times the time. Example, you borrow $2,500 at 4% interest for a 3-year term. $2,500 is your principal, 4% is your rate, and then T right here, time, is 3 years. How much interest will you be charged, and what amount of money will you pay back in the 3-year period? So how much interest will you be charged? I equals principal, 2,500, multiplied by rate, 0.04, multiplied by time, which is 3. Simply grab a calculator and multiply that together, and I might as well just keep this Desmos on the screen. We'll be doing lots of calculator work today. 2,500 times 0.04 times 3, you'll be paying $300 in interest. That's the first answer to the first question. Second question, what amount of money will you pay back? Well, you'll be paying back the original $2,500 plus $300 interest. So that's $2,800. So that's simple interest. I just want you to see how that works. A lot of current, in this day and age, current loans are figured in this way. Principal, rate, time, multiply it together, that's it. If you watched the video and did the ed puzzle on the number E, you will have seen these other two formulas. If you haven't seen it yet, you should go back and watch that. It gives you a little background. These formulas just calculate A. They don't calculate I. You can always do a little subtraction in the end to figure I if you want to, but we're just going to concern ourselves with A. Compound interest is where interest is calculated more than once per year. So if you calculate interest twice per year, you actually divide the rate by 2, so you get half the interest rate, but it happens twice per year. And it actually changes things. You wouldn't think so. Dividing by 2 and then doing something twice, you'd think would cancel out, but it doesn't. It actually changes things. With an investment, you earn more money. With a loan, you pay back more money. Better for the bank that way. Now, before we get into this, we need to know what the letters stand for. So A, again, is the final amount. P is principal. Rate is time. N is the new variable. It's not in the previous simple interest formula. N is the number of times per year that interest is compounded or calculated. Again, t is the time in years. If you're ever given a problem with months, like a 48-month loan, well, 48 months is 4 years. So we just make t equal to 4. So don't let that get out of hand if it ever comes up. Briefly, I want to talk about different types of n. Semi-annually. Semi means half, annually means year. Every half a year means twice a year interest is calculated. Quarterly is every 3 months. So 4 times per year interest is calculated. Monthly interest is calculated 12 times a year, right? 12 months in a year. Bi-monthly means twice per month, so that'd be n would be 24. Weekly interest is calculated 52 times per year, 52 weeks in a year. Daily interest is 365 times, maybe 366 if it's a leap year. There are even credit cards that calculate interest twice daily. So over 700 times per year, interest is calculated, and that really puts money in the pockets of the bank. Now, there's no example here because there's lots of examples in the assignment. So that's compound interest. For continuous interest, or compounded continuously, there is no finite number like 52, 24, 365. Interest is always compounded, non-stop, so infinitely many times per year. And this is the formula that does that. P still stands for principal, A still stands for amount, E is that special number, 2.71 something, something, something. It goes on forever. It's an irrational number. The rate, again, percentage, move the decimal 2 places, time in years. So this formula kind of works like magic, and it makes infinite interest possible. Now you might say, oh, infinite interest means infinite dollars, and that doesn't make any sense. It is infinitely many times the interest is charged, but each time it's charged, it's extremely, extremely small. So it does still work out to be a finite or a whole number answer, or an actual real number answer. All right, before we get into the actual problems, because we're about done with as far as notes is concerned, this same formula does appear in science, and you might see it like this in function notation, or it might exist like this with n and n sub 0, n1, n0. These are for any sort of growth or decay. So the first one you might see in biology for population growth, be it bacteria in a petri dish or a number of bald eagles in a particular state. You can use this formula to model that growth. The second one could also be used for growth, or it can be used for decay, like radioactive decay. The same formula works. The difference is in the rate. So in science, they tend to use K instead of R. I'm honestly not sure why. When K is positive, that's growth, but if K is a negative number, that's actually decay. So this formula has lots of different applications. For us, we're only going to focus on the financial application right now. All right, in all of the formulas above, any variable can be solved for. We could take P, A, R, T, any of them, and make them an unknown, and then you could do algebra to solve for it. In this worksheet, we're going to be mainly focusing on A and T. So just let that be known. You can do lots of different math with this. We're going to focus on solving for A, solving for T. Here's what it's going to involve. You're going to read the problem. You're going to use the context to choose the formula that's proper. You're going to plug in the numbers, and then you're going to solve it. So I'm going to scan through here. Invest this much money at an interest rate of this much, compounded 4 times a year. How much will be there in 13 years? This is the compound interest formula. About to write that backwards. A equals P, 1 plus R over N to the NT. So plug in the numbers. Principal is the starting amount. 1 plus R over N, that's 1 plus. The R is 7%, so that's 0.07. The N is 4 times a year, so put a 4 down there. To the 4 times 13 power, and then that all equals A. So this is pretty much a straightforward problem. We just need to plug this into the calculator and work out the answer. So 2679 parenthesis 1 plus 0.07 over 4. Now, I need to raise this to the power that says 4 times 13. Watch what happens when I type in 4 times 13. Desmos put the 13 in the wrong spot. We get $37,000. That's no way that's true. The 13 needs to be up there. So with Desmos, what you need to do is parenthesis 4 times 13 and do that to get the right answer. So $6,603, 32 cents. That should be the answer to number 2. If I can ever scroll down enough, there it is. So there you see it. In 4 years, $2,600 went up to $6,600. All right, let's look at number 4. Same kind of a problem. We want to invest a principal amount into a savings account with an interest rate R of 3%, compounded 6 times per year, that's N. What will the balance be, the amount, that's what we're looking for, after 12 years? 12 is the time. So A equals 7,044 times 1 plus 0.03 over 6, not 3 over 6, 0.03 over 6, to the power of 6 times 12. Type that into Desmos or whatever calculator you like to use, and you should be good to go. So 0.03 over 6 raised to the power, and again I have to use parentheses, 6 times 12, $10,087.32. So you can see why people invest money, because you get more money back. All right, so 2 and 4 were basically applications of this formula where we're solving for A. They're pretty straightforward. You just type it all in the calculator, get your answer. 5 through 8 are going to be a little different. Now, the key word in here is still compounded, so it's going to be the same formula. I'll write it down here. But different things are given. Mark invests $3,931 in a retirement account, so that's the principal, at a fixed interest rate of 8%, that's our R, it'll be 0.08, compounded 4 times a year, so N is going to be 4. How long will it take? All right, I'm going to highlight that phrase in yellow. How long will it take? That is telling us that T is unknown. For the account balance to reach $19,165.35. That is A, the final amount. So the T is unknown in this problem. The numbers get plugged in everywhere else. 19,165.35 equals 3,931 times 1 plus 0.08 over 4 to the 4t power. And now we need to solve that. You cannot just directly type this into the calculator. You need to do some solving. First off, what's in parentheses can be simplified. Simple is better. 1 plus 0.08 over 4. So let me rewrite this problem with that one simplification made. Oops. So what is that? 1.08. Oh, darn it. I forgot to hit the divide button. Ugh. 1.02. Sorry about that. Okay. Now, we've got over here on this side, 3,931 times 1.02 to the 4t. You cannot actually multiply these together because 1.02 is attached to a variable power. So it kind of makes it an unlike term. You cannot multiply those. Instead, what you need to do, Instead, what you need to do is solve this like an algebra problem. This is times, so you need to divide both sides by 3931. Cancel that out, and then, yeah, obviously grab a calculator. 19165.35 divided by 3931. Gosh darn it. Okay, if I don't talk while I do it, I have a better chance at doing it right. So 4.8754 equals 1.02 to the 4t power. So we're solving this for like an algebra problem. We're trying to solve for t. T is in the power. That means we need to cancel out this base. How do you cancel out a base? What have we been learning about all this time? Logarithms. Take the log base 1.02 of both sides. This cancels out. I get 4t on the right. On the left, I use my calculator. So log base 1.02 of 4.8754, 79.99959. Okay, that looks to me to be 80. And we are trying to calculate this to the nearest year. 80 divided by 4 is 20, so 20 years is how long it'll take to turn $3,931 into $19,165.35. Let's check number 6 and make sure. There it is. And did I not check number 4? 10,087 and 32. There it is. If I forgot to check it before, sorry about that, but we're good. Okay, number 8 is going to be very much like number 6. So compounded, so we're going to use the same compound formula. Principal is the original amount that's put into the savings account. R is the percentage. N is the number of times per year. How long will it take? T, that's telling us T is the unknown. To reach a balance, the balance is the final amount. So $5,233.33 equals 3767, 1 plus 0.03 over 4 to the 4t power. Let's solve this. First, simplify that. Use a calculator, make it easy on yourself. 1 plus 0.03 divided by 4. 5233.33, 3767, 1.0075 to the 4t. Now, divide both sides by 3767. 5233.33 divided by 3767. Try to round off correctly whenever you can. Here, there's quite a bit of rounding when you're going to the nearest year, so it's not a big problem if you make a little mistake. Usually will correct itself. All right, now we need to do the logarithm of both sides. Log base 1.0075. Log base 1.0075. Logs cancel out bases. The next step I have to do on the calculator. So the base is 1.0075 and 1.3893. I'm just going to call that 44 because when you divide by 4 on each side, you get 11 years equals t. That should be the answer to number 8. Where is it? There it is right there. Okay, so the first 8 problems all involve this formula. All right? The first 4 are straightforward. The next 4 are sort of working backwards and using a logarithm. Next, Perry invests. Okay, we've got a principal amount in a retirement account, fixed rate, that's a rate, percentage. What will be the account balance after 16 years? That's time. Okay, what's going on? What's so different? Well, here we see compounded continuously. They don't give us an N number, but they do use the word continuously. That tells us we need to use the other formula, A equals PE to the RT. So plug those numbers in. We're solving for A. What will the account balance be? We don't know. But the principal is 4201. E is that constant. R is 0.07 times T times 16. Just type this in the calculator. There's nothing to really solve algebraically. Remember, to get e, use the alphabet button. And then to raise this to a power, 0.07 times 16. And we get $12,875.45. And wow, that almost, well, that more than triples the money. Now you can see why it's a good idea to make investments. Let's check number 10 though, make sure I didn't mess anything up. Yep, $12,875.45. Looks good. Number 12 now is just repetition. We have, again, the key phrase compounded continuously. A equals P e to the RT. So A we don't know. Principal 2266. E is the constant. R is 0.02 multiplied by the time of 12 years. Type that into Desmos. 2266 E raised to the 0.02 times 12, $2,880.65. Check number 12. Oops, went too far. There it is. All right, so those 4 problems, hopefully you can handle those, you can deal with them. I don't want you to have any issues with that. Let's look at the last set of 4 problems. If I zoom in here, the first thing that catches my eye, I do see compounded continuously. So that's telling me it's the same formula. But how long will it take? T, again, is the unknown. We're investing just over $8,000, just under $9,000. That's the principal. Here's our rate. Rate is always the one with the percent. And to reach an account balance of this amount, that's our A. So 19,783.84 equals 8801 times E to the 0.09 times T power. Okay, I'm going to write that more neatly. That just looks awful. Let's just go 0.09 T like that. So how do we solve this? Well, first I'm going to divide by 8801. And I definitely need a calculator for that. Okay, did I type that in correctly? Good. Divided by 8801, so 2.274. Nope. Wow, I think I might be a little sleepy. I'm doing silly mistakes. There we go, equals e to the 0.09 t. Why did I leave a space in front of the e? Well, because to cancel out a base, we need a logarithm. I need space for the logarithm. Of course, we use the natural log when dealing with base e. So now get your calculator and do the natural log of 2.2479. Missed a digit, 2479. 0.801 equals 0.09 t. Divide both sides by 0.09, and hopefully we get a number that is the right answer. 0.801 divided by 0.09. 8.9. Now with the rounding off, I have a feeling that our answer key is going to call this 9 years. I think we are finding answers accurate to the nearest year, and there it is. All right, last one, and we are done. Again, continuously is the key word that tells us to use this formula. Here's our P, here's our R. T is the unknown because it says how long will it take. A is the final account balance. 9011.51 equals 7378 e to the 0.05 t. Plug in the numbers, work out the answer. Divide by 7378. Definitely need a calculator for this. 9011.51 divided by 7378. 1.2214 e to the 0.05t. How do you cancel out e? With a natural log. That's how. Natural log both sides. ln 1.2214 0.2 equals 0.05t. Right? There's so many 9s there, they'll all round up and give us 0.2. Divide both sides by 0.05. 0.2 divided by 0.05 equals 4. Call that years, and we should be done. And there it is. Okay, so your assignment, very straightforward. The problems that you're doing are just like the even problems right next to the ones that, right next to them. So the ones that I did should totally explain how you are going to do the ones you need to do. All right, I'm going to stop there. Contact me through the normal means if you have questions. Otherwise, I'll talk